Hi, this stats video is going to be a quick lesson on the different measures of center, or different ways we can represent the middle of a data set. So first of all, the most common way to measure the center is the mean, which is also very often called the average. So the mean, as with any average, we add up all the values and we divide by the number of values. So we have some specific notation that we use in statistics for that. So quick reminder, this Greek letter here, sigma, represents the sum of whatever follows behind it. In this case, that's going to be x. So we have sum of x, that means add up all our x values. Now we have two different symbols for the mean, and you'll notice in one calculation we're dividing by a lowercase n and the other we're dividing by capital N. The only difference there is that is looking at sample versus population. So with the x with a bar on top, that's our symbol for the sample, and this Greek letter, which is mu, is looking at the calculation for the population. Other than that, these two calculations are identical. So this notation, very often in statistics, we use Greek letters when we're talking about the population, and our standard Roman letters, maybe with something like a bar on top, when we're talking about a sample. So use the appropriate one for the particular question. So we're going to look at this first question, where we have some point thickness readings, and we're asked what is the mean thickness. So if we look at this, we've got 20 points. We can add up those 20 points. When we're looking at writing down our work, make sure that you are showing all your steps. So write your formula, that summation symbol, you can go straight to the total. It's okay though if you wanted to say equals 15 plus 19 plus 14, etc. And we divide by our number of data points, so this is 20 data points. So you plug that into your calculator, we get 19.75. Don't forget units, right? Units are always very important. So this is the answer our calculator has, but we always want to round to one more placeholder than the raw data when we're doing means in statistics. So a heads up, our significant figures in statistics has some very specific rules on different applications. So in this particular application, calculating a mean, it's one more placeholder than our raw data. So in this case, we would round to 19.8 millimeters. You may also want to look at doing that on a statistical calculator or a computer. So Excel, if we want to find an average in Excel, well, there actually is an average function. So that one's pretty straightforward. A little comic for fun. So example 2 that I've got here is one to try on your own. I've put some steps on some different types of calculators. So the first one is your typical scientific calculator, but it's a little bit vague because different calculators have different steps. So when uncertain, look in your instruction manual for your particular calculator. If you don't have the instruction manual for your particular calculator, the good news is most of them are available online. Just Google the particular model you have and you'll often find the manufacturer's site and your manual. Steps over here are for your typical Texas Instrument graphing calculators, so that's the TI-83 or the TI-84. Again, detailed instructions would be in your instruction manual or online. I suggest you pause the video at this point and just try to do this particular question. Now, do you have to do it using the statistical functions on your calculator? Absolutely not. But it is a tool that you can put into your toolbox because knowing how to use those stats functions on your calculator will be handy when we do some of the more complex calculations. So if we look at that particular question and calculate our mean, we get 8.0. Now, there was no units in our original question, so we're not going to have units here in our answer either. If there were units in the original question, make sure you include units. You'll notice I did go to one more decimal place than the original data. if we need to calculate the mean for a set of grouped data, such as in a frequency table, we have to do things a little bit differently. So instead of just saying the sum of all the x's, we have to weight the x's by their frequency. So we need to take the frequency of the first group times that first x value plus the frequency of the second group times the second x value. Now, if we have a data set that covers a range, what do we use for our x value? Pause a moment and think about that. Right, so like this example here. What would we use for our x value if our value is between 40 and 49? Instinct probably tells you, well, let's go halfway in between. And in fact, that's exactly what you do. You use the class mark, to use our terminology from chapter 2. So we take that class mark, and then we're going to multiply that class mark times the frequency, right? So that's going to be our first f1, x1 to get that first group. So we multiply that and we get a value. Likewise, we would do the same in the second category, so 54.5 times 3 to get our second value. And continuing on down, we would calculate all the rest. Again, you may want to pause the video, take a moment, verify that these calculations work for you, that you know how to do them. So now if we look at our formula, right, it's the sum of each fx product. So we've got those f times x, I put it as x times f, but same thing. So if I look at the sum of that, right, that's just going to be my value when I total this up. Divided by n. Now there's a very, very common mistake that people make here when using a value for n. So I want you to pause a moment and think, what is my value for n? If you looked at this table and you went, well, I've got 1, 2, 3, 4, 5, 6 data points, and set, so then my n would be 6, that's the common mistake. In fact, you have 2 data points that are somewhere between 40 and 49, 3 data points that are somewhere between 50 and 59, and so on. So your n is actually the total of this frequency column. So we need both those totals, the total of the frequency for our n, and the total of the x times f, or f times x, for the top of our calculation. Once we have those two totals, we can plug them into our formula and calculate the overall mean. So in this case, that works out to 70.15. And again, if our raw data is to the nearest whole number, and remember, it's the values that were in our original table before we put in these class marks. So we can see, oh yeah, 40 to 49, 50 to 59, that's to the nearest whole number, so we're going to round to the nearest decimal. Units in this particular case are just percentage. So that's sort of the two variations of mean that are important to know, just looking at the mean straightforward average and the frequency table average. When you look at those two, which one would you consider to be more accurate? The one that we calculate from a frequency table, or the one that we calculate from the raw data? If you think about it, the frequency table is actually an average of estimated values, right? We don't know that these 2 data points average out to 44.5, or that these 3 average to 54.5, or so on in the next categories. We're saying, well, it's going to end up around that value. So we've made an estimate here by using the class mark. So because we are taking an average of an estimate, the frequency table is not going to give us as accurate of an answer as if we have the raw data. So if you have both the raw data and a frequency table, and you've got a choice, your best bet is to go with the raw data. But sometimes you don't have the raw data, you've got your information from some other source, you may have to do it this way. Okay, so we're going to look at a few other ways of measuring the center, because the mean is only one way of doing it. And we're going to use the same point thickness example, that 20 data point set, and we're going to use another example that is servings of fruits and vegetables eaten. So the first, I should say the second, because the mean was the first. The second way of looking at the center is something called the median. And that's the middle value when we arrange all the values in order. So if we're doing this by hand, we actually have to rearrange the data points. So if I want to find the median from this blue data set, the fruits and vegetables eaten, first I've got to rearrange it. And then I literally count towards the middle. So I go 1, 2, 3, 4, 5. That gets me to the middle point, because 1, 2, 3, 4, 5 from the other end gets me to the same point. Right? So I just count in from either end till I get to that same center point. And I see that in this case, the middle number is 6, and our units on that was servings. If we look at the point thickness example, when we count in, right, there is an even number. So we've got 10 data points there, 10 data points there. So if I have two numbers that are the middle numbers, I have to take the average of those two numbers in order to get what the median is. And I see I highlighted the wrong things. That was 10. And that was the other 10. So the middle point between those two, right, halfway between 19 and 20, is going to be 19.5. So we have to deal with an odd set of numbers a little differently than we deal with an even set of numbers. Now, very often, if we have a really large data set, hundreds or thousands of numbers, those two middle points are going to be the exact same number, so it makes no difference. So the median is often used when we have a skewed data set. Remember, that's where we have that bump more to the left or more to the right, because we have some outliers on the other end. So when we have a skewed data set or we have outliers, they're really going to affect the mean. For example, if you were to look up housing prices, usually they list housing prices by the median. If you're looking at housing prices in a particular area, they'll tell you the median house price in that area. And the reason is it just takes one exceptional house to really skew that data, because you're usually dealing with smaller data sets, not as many data points to calculate those means of recent house sales. So if you're in a market where most of the houses are selling for around $400,000, but there's one house in that market that sells for $1 million, and you've got 10 sales that month that they're doing the calculation for, suddenly that $1 million house is like really skewing the market. So instead of looking at the mean, you would look at the median, because the middle point is still going to be your typical house. So the mode is the score that occurs most frequently. So sets of numbers do not always have a mode. So some sets of numbers have no mode. Other sets of numbers are bimodal, meaning they have two modes, or multimodal, meaning they have more than two modes. And when you're looking at the mode, these things can happen, so you've got to consider that it's not necessarily going to be a single mode. So if we look at that example, going back up to the servings of fruits and vegetables, we can see 4 repeats, 7 repeats, nothing else repeats. So the number that we have the most of, or the mode, is both 4 and 7. So those two together are each going to be a mode. Whereas if we look at this point thickness data, well, we have various numbers that repeat, 15 repeats, 18 repeats, 20 repeats, 22 repeats, there's 3 of them, right? So that's the one that's actually our mode. So if it repeats, that doesn't tell us for sure it's a mode, it's the one that happens most often. So for our thickness data, 22, oops, that should have millimeters on it, is the mode. Likewise, these ones should say servings. Mid-range is used as a quick estimate, and if we're looking at mid-range, it's never going to be your final answer, but it is super quick. So mid-range is halfway between the top and the bottom scores. So if we look at something like example 3 that we had earlier, our top score was 99, our bottom score was 40. Mid-range, we would add those two up, which would get us 139, and divide by 2, which would give us 69.5. So we end up not right where the mean was, but we can see that, oh yeah, we were in the right approximate place. So that's what the mid-range is good for. I didn't mention it when I was talking about the mode, but one of the things the mode is good for is looking at nominal. Remember, that's category data. So if you're figuring out, the most popular brand of phone, for instance, we can't do that as a calculation because that's not a number, but we can say this one is purchased more often than any other one. Okay, so if we look at those same data that we had there, the servings of fruits and vegetables, our mid-range, we add the 3 plus the 9 and divide by 2, and we get a mid-range of, 6. Our point thickness, again, we take the bottom, which is 12, and we take the top, which is 29. Find our average, we get 20.5. A fifth way of calculating center point is a weighted mean. That is just like the frequency table mean, right? Except instead of frequency, we would replace it with weight. So that sort of thing gets used in course grades, right? Where your tests might be worth 30%, your final exam's worth 40%, your assignments are worth 20%, right? And you add those up accordingly. So again, a couple examples to try here. I suggest you pause the video, actually work them out, and see how well you do. Assuming you took that time and paused the video, looking at our answers, we get for the first one, the mean is 6.64 centimeters, the median is 6.3 centimeters, and the mode is 5.6 centimeters. On the second set of data, we get the mean is 38.8 kilojoules, and you'll notice, right, that rounding, this went to one more decimal place than the raw data. This rounding went to one more decimal place than the raw data. Median, this was an even set, so we had to go halfway between the middle two, and there was no mode in this one. So sometimes our answer to mode is that it does not exist, and that's okay. So all of these measures of center are important and can be used in varying circumstances, but some are better for some circumstances and some are better for others. And it somewhat goes back to what type of data we were talking about. So nominal data, as I already mentioned when we were talking about mode, your best measure of center is, your only measure of center is the mode, right? It's not only the best, you can't calculate a mean or a median if we're talking about nominal data. Ordinal data, remember, that's things we can put in order, like ratings. So the best bet there is median, because again, those numbers don't actually mean anything. If we have a 5-star rating or a 2-star rating, how do I calculate an average? So instead of calculating an average, we say, well, of all the ratings that were given, the middle one is such and such, right? The median one. Interval or ratio data that is not skewed, your best bet is the mean. So there's an awful lot of data sets that we'll use the mean on because they fit into this category. However, if it's skewed, we might calculate the mean, but we might also calculate the median so that we can work that out. So there's our summary of our mean, median, and mode. I hope that was helpful.